Mercury, the smallest planet in our solar system and nearest to the Sun, is only slightly larger than Earth's moon. Its surface is covered in tens of thousands of impact craters. Despite its proximity to the Sun, Mercury is not even the hottest planet in our solar system. But Mercury is the fastest planet, zipping around the Sun every 88 Earth days. Buckle up for our journey around the solar system as we explore the swift planet Mercury. Number 1. Extreme temperatures. Mercury's lack of atmosphere means it has no protective blanket to retain heat. During the day, its surface is bombarded by intense solar radiation, causing temperatures to skyrocket to about 430 degrees Celsius, 800 degrees Fahrenheit. This extreme heat could even lead to the vaporization of certain metals. Without an atmosphere to retain heat, Mercury's nighttime temperatures plummet to as low as -180 degrees Celsius, -290 degrees Fahrenheit. This stark temperature difference between day and night is due to the planet's slow rotation, allowing its surface to cool rapidly during the long night. Mercury has an eccentric orbit, meaning it is not a perfect circle. This orbital characteristic intensifies the variation in solar heating, contributing to the planet's extreme temperature fluctuations. Number 2. Shortest day, longest year. Mercury's rotation is exceptionally slow, taking approximately 59 Earth days to complete one rotation on its axis. This is in stark contrast to its relatively fast orbital period around the Sun, completing an orbit in about 88 Earth days. The peculiar 3.2 spin-orbit resonance means that Mercury rotates on its axis 3 times for every 2 orbits around the Sun. This resonance is a result of gravitational interactions with the Sun during the planet's formation. Due to its slow rotation and rapid orbit, a day on Mercury, one complete rotation, lasts longer than its year, one orbit around the Sun. This unusual dynamic results in unique day and night lengths on the planet. Number 3. Large temperature swings at poles. Mercury's poles contain craters that are permanently in shadow, never receiving direct sunlight. These shadowed areas have temperatures low enough to sustain water ice, a surprising discovery given Mercury's proximity to the Sun. Observations from the Messenger spacecraft revealed evidence of water ice deposits within these permanently shadowed craters. The origin of these icy deposits is still a subject of scientific investigation. The stability of water ice on Mercury's surface is influenced by the planet's proximity to the Sun and the continuous bombardment of solar wind. Understanding how water ice persists in such an environment provides insights into the dynamics of volatile elements on rocky planets. Number 4. Unusual surface composition. Mercury's surface primarily consists of rocky terrain, resembling the heavily cratered landscape of Earth's moon. Impact craters cover much of the planet's surface, reflecting its exposure to space debris. In addition to craters, Mercury's surface features smooth plains, believed to result from volcanic activity. The volcanic eruptions covered older, cratered areas with a layer of more recent smooth material. The surface composition of Mercury includes elements like iron, making it distinct from other terrestrial planets. This iron-rich composition contributes to the planet's unique appearance and geological features. Number 5. Tectonic activity and scarps. The presence of large cliffs or scarps on Mercury's surface indicates past tectonic activity. These scarps are thought to have formed as the planet's interior cooled and contracted, causing the surface to crack and create dramatic geological features. The scarps on Mercury are not limited to specific regions, but are observed globally. This suggests a history of widespread tectonic activity, shaping the planet's surface over time. The Messenger spacecraft provided detailed images and data that significantly advanced our understanding of Mercury's tectonic history. The mission confirmed the presence of extensive tectonic features, adding a layer of complexity to the planet's geological story. Venus, the cloud-swaddled planet, our nearest planetary neighbor and often referred to as the Earth's twin. But let's put it like this. In some ways, it is more an opposite of Earth than a twin. Venus spins backward, has a day longer than its year, and lacks any semblance of seasons. It might once have been a habitable ocean world, like Earth, but that was at least 1 billion years ago, thanks to the runaway greenhouse effect. Buckle up for a tremendous journey as we discover the most hellish planet in our solar system, Venus. Number 1. Extreme atmosphere. Venus' atmosphere is so thick that it intensifies the greenhouse effect. The high concentration of carbon dioxide traps heat, causing a surface temperature hot enough to melt lead. The clouds in Venus's atmosphere are primarily made of sulfuric acid droplets. These clouds play a crucial role in reflecting sunlight back into space, contributing to Venus's high albedo, which is the measure of how much sunlight a planet reflects. The thick clouds also make the planet's surface difficult to observe directly. Despite its slow rotation, Venus experiences incredibly high-speed winds in its upper atmosphere. The winds can reach speeds of up to 360 kilometers per hour, 224 miles per hour. The fast-moving atmosphere creates a super-rotation, where the atmosphere rotates much faster than the planet itself. Number 2, retrograde rotation. Venus rotates on its axis from east to west, the opposite direction of most planets in the solar system, including Earth. This retrograde rotation is still not completely understood and remains a topic of scientific investigation. The cause of Venus's unique spin is believed to be influenced by complex interactions during its early formation. There's a possibility that Venus is in a state of tidal locking with the Sun, meaning the same side always faces the Sun. While this is not confirmed, it adds an intriguing layer to Venus's rotational dynamics and could explain its retrograde rotation. Due to its retrograde rotation, if you were standing on the surface of Venus, you would witness the Sun rising in the west and setting in the east. This is the opposite of what we experience on Earth and most other planets. Number 3, lengthy day and night. Venus has an exceptionally slow rotation on its axis, taking about 243 Earth days to complete one rotation. This is longer than it takes for Venus to complete one orbit around the Sun, making a day on Venus, from one sunrise to the next, shorter than its year. The solar day on Venus, based on its sunrise to sunrise cycle, is about 117 Earth days long. However, the sidereal day, based on its rotation relative to distant stars, is about 243 Earth days. This discrepancy is due to Venus's retrograde rotation. On Venus, the transition between day and night is gradual, not sudden. This is because the thick atmosphere scatters sunlight, creating a diffused twilight that lingers for a long duration after sunset and before sunrise. Number 4, volcanic activity. Mont Mons is one of Venus's prominent shield volcanoes, reaching heights of about 8 kilometers, 5 miles. It is believed to be one of the most recently active volcanoes on the planet. Venus's volcanic activity is not limited to specific regions, but is distributed across the entire planet. The presence of volcanic plains suggests a history of extensive volcanic eruptions shaping the planet's surface. creating vast lava plains and unique geological structures. Number 5. Venera 7. Launched by the Soviet Union in 1970, Venera 7 made history as the first spacecraft to land on Venus and transmit data from its surface. It revealed extreme conditions, including scorching temperatures over 465 degrees Celsius. The transmission, lasting 23 minutes, marked a milestone in space exploration, opening the door for further missions to study Venus. Venera 7's success significantly contributed to our understanding of Earth's neighboring planet. Earth, our remarkable home in the vast cosmos, a planet of unparalleled diversity and complexity. Nestled in the habitable zone around the Sun, it teems with life, boasts a dynamic geology, and stands as the only known celestial body with liquid water on its surface. Buckle up as we take a journey around our home, Earth. Number 1. Composition and layers. Earth is composed of several layers, each with distinct characteristics. The innermost core, primarily consisting of iron and nickel, is solid due to high pressure. Surrounding the core is the outer core, where molten metal generates Earth's magnetic field. Above this lies the mantle, composed of solid rock that can flow over geological timescales. The outermost layer is the Earth's crust, which includes the continents and ocean floors. Number 2. Unique water distribution. Earth is the only planet known to have liquid water on its surface, crucial for supporting life as we know it. Oceans, covering about 71% of Earth's surface, contain approximately 97% of the planet's water. The remaining 3% is fresh water, found in glaciers, ice caps, and underground reservoirs. This dynamic water distribution plays a vital role in shaping Earth's climate and ecosystems. Number 3. Dynamic plate tectonics. Earth's lithosphere is divided into tectonic plates that constantly move, leading to geological phenomena such as earthquakes, volcanic eruptions, and the creation of mountain ranges. This dynamic process, known as plate tectonics, shapes the Earth's surface over vast timescales, influencing the continent's positions and altering landscapes. Number 4. Magnetic field and solar wind protection. Earth's magnetic field, generated by the movement of molten iron in its outer core, acts as a protective shield against the solar wind, a stream of charged particles from the sun. This magnetic shield prevents the solar wind from stripping away the Earth's atmosphere, making it a crucial factor in maintaining the conditions necessary for life to thrive on our planet. Number 5. Microbial underground biosphere. Beneath the Earth's surface lies a mysterious and largely unexplored realm known as the deep biosphere. In this hidden domain, microorganisms thrive in extreme conditions, such as high temperatures and pressure. The microbial life in the subsurface is believed to be vast, potentially harboring unique species and adaptations yet to be discovered, offering a tantalizing glimpse into the resilience of life on our planet. Mars, our solar system's fourth planet from the Sun. The red planet has long been a subject of fascination for scientists and dreamers alike. With a thin atmosphere, colossal volcanoes, and an extensive canyon system, Mars unveils a geological narrative that beckons exploration, offering tantalizing clues about the potential for past life and paving the way for future human endeavors beyond Earth's bounds. Buckle up for an interstellar adventure as we journey together to unravel the enigma that is the captivating world of Mars. Number 1. Iron oxide surface. Mars is often referred to as the red planet due to its distinct reddish appearance, which is a result of the iron oxide, rust, on its surface. The Martian soil contains a high concentration of iron, giving the landscape a rusty color. The iron oxide not only gives Mars its unique visual identity, but also plays a crucial role in shaping the planet's surface features. The distinctive appearance of Mars, observable from Earth, is a direct result of this iron-rich composition. Studying the iron oxide on Mars provides scientists with valuable insights into the planet's geological history and the environmental processes that have influenced its surface composition over time. Number 2. Olympus Mons. Olympus Mons stands as a colossal shield volcano, towering approximately 13.6 miles, 22 kilometers high. This makes it the tallest volcano in the solar system, nearly 3 times the height of Earth's Mount Everest. Beyond its impressive height, Olympus Mons boasts a remarkable diameter of around 370 miles, 600 kilometers, making it one of the widest volcanoes known. Its size dwarfs any volcanic feature on Earth. The study of Olympus Mons provides insights into the geological processes that have shaped Mars. Understanding the formation and history of this massive volcano contributes to our broader understanding of planetary geology. Number 3. Valles Marineris. Valles Marineris is a colossal canyon system stretching approximately 2,500 miles, 4,000 kilometers, in length. This makes it the longest canyon in the solar system, far surpassing the Grand Canyon on Earth. With depths of up to 7 miles, 11 kilometers, and widths reaching up to 370 miles, 600 kilometers. Valles Marineris showcases the immense geological diversity of Mars. The canyon's proportions are truly staggering. Scientists aim to unravel the mysteries of Valles Marineris, exploring the geological processes that led to its formation. The canyon system provides a window into Mars' complex geological history. Number 4. Frozen water ice. Mars features polar ice caps at its poles composed of water and dry ice, frozen carbon dioxide. These caps undergo seasonal changes, expanding and contracting with the shifting Martian seasons. In addition to surface ice, Mars harbors vast underground reservoirs of water ice. These hidden reservoirs are crucial resources for potential human exploration and colonization, offering a potential source of water. The study of Martian ice contributes to our understanding of the planet's climate history and potential habitability. Water, in its various forms, plays a key role in shaping the Martian environment. Number 5. Thin atmosphere. Mars possesses a thin atmosphere primarily composed of carbon dioxide with traces of nitrogen and argon. The atmospheric pressure on Mars is a mere 0.6% of Earth's surface pressure, making it challenging for human habitation without life support systems. The thin atmosphere contributes to significant temperature variations on Mars. Daytime temperatures can reach around 70 degrees Fahrenheit, 20 degrees Celsius, near the equator, while nighttime temperatures drop drastically. Understanding these variations is crucial for planning future missions. Mars's thin atmosphere presents challenges for human exploration, but it also offers opportunities for innovative engineering solutions. The study of Martian atmospheric conditions is essential for designing spacecraft, habitats, and life support systems for future missions. Jupiter, the 5th planet from the Sun, and by far the largest planet in the solar system, more than twice as massive as all the other planets combined, carries a ton of fascinating facts to be discovered. Buckle up as we dive into the colossal gas giant Jupiter. Number 1. Gigantic size and mass. Jupiter is the largest planet in our solar system, with a diameter of about 86,881 miles, 139,822 kilometers, more than 11 times that of Earth. Its mass is approximately 318 times greater than Earth's, and its volume is over 1,300 times that of our planet. The immense size and mass of Jupiter make up about 70% of the total mass of all the planets in our solar system combined. Number 2, powerful magnetic field. Jupiter boasts an incredibly strong magnetic field, around 14 times more powerful than Earth's. This magnetic field is generated by the planet's rapid rotation and the presence of metallic hydrogen in its interior. Jupiter's magnetosphere is so vast that it extends well beyond the orbit of its largest moon, Ganymede, making it the largest planetary magnetosphere in our solar system. Number 3, rapid rotation. Jupiter is a fast spinner, completing a full rotation on its axis in about 9.9 hours. This rapid rotation causes the planet to be noticeably oblate, meaning it is slightly flattened at the poles and bulging at the equator. The combination of its rapid rotation and massive size contributes to the flattening effect, making Jupiter an oblate spheroid. Number 4, Jupiter's moons. Jupiter has an extensive family of moons, with over 80 known natural satellites. The 4 largest, known as the Galilean moons, Io, Europa, Ganymede, and Callisto, were discovered by Galileo Galilei in 1610 and are among the most fascinating objects in our solar system. Each of these moons has unique characteristics, including volcanic activity on Io, a subsurface ocean on Europa, and being the largest moon in the solar system, Ganymede. Number 5, the Great Red Spot. Jupiter is renowned for its Great Red Spot, a massive storm that has been raging for at least 350 years and possibly much longer. This anticyclonic storm is larger than Earth itself, with winds reaching speeds of about 270 miles per hour, 430 kilometers per hour. The exact cause of the Great Red Spot's longevity is not fully understood, but it remains one of the most prominent features on Jupiter's surface. Saturn, the 6th planet from the Sun. Known for its dazzling ring system, Saturn is a gas giant of colossal proportions, second in size only to Jupiter. Buckle up as we dive into the majestic ringed giant Saturn. Number 1, gigantic size and mass. Similar to Jupiter, Saturn is a gas giant and ranks as the 2nd largest planet in our solar system. Its diameter is approximately 74,900 miles, 120,500 kilometers, making it about 9 times wider than Earth. Despite its immense size, Saturn's density is lower than water, meaning it would float in a giant bathtub if one were large enough. Number 2, rapid rotation and oblate shape. Saturn rotates rapidly on its axis, completing a full rotation in about 10.5 hours. This fast rotation, combined with its gaseous nature, causes the planet to be noticeably flattened at the poles and bulging at the equator, giving it an oblate spheroid shape. The oblate shape is more pronounced in Saturn than in any other planet in our solar system, contributing to its distinctive appearance. Number 3, unique hexagonal storm. Saturn's North Pole is home to one of the most intriguing atmospheric phenomena in the solar system, a hexagonal-shaped storm. This massive and persistent 6-sided pattern in the clouds surrounding the pole was first observed by the Voyager spacecraft and later confirmed by the Cassini mission. The exact cause of this hexagon is still not fully understood, but is thought to be related to atmospheric dynamics and the planet's rotation. Number 4, extensive moon system. Saturn has an impressive collection of over 80 known moons, each with its own unique characteristics. Titan, Saturn's largest moon, is of particular interest due to its thick atmosphere and the presence of lakes and rivers of liquid methane and ethane on its surface. Enceladus, another moon, has geysers that spew water vapor and ice particles into space, suggesting the possibility of a subsurface ocean. Number 5. Spectacular ring system. Saturn is renowned for its stunning and extensive ring system, which consists of thousands of individual ringlets made mostly of ice particles and rocky debris. These rings span hundreds of thousands of kilometers, but are incredibly thin, measuring only a few meters in thickness. The origin of Saturn's rings is believed to be the result of interactions with moons and comets. Uranus, the seventh planet from the Sun, stands as an enigmatic celestial body in our solar system. Uranus presents a captivating puzzle for astronomers. Buckle up as we discover the sideways planet. Number 1. Discovery. Uranus was the first planet discovered with a telescope. German-born British astronomer Sir William Herschel observed it on March 13, 1781. Initially, he thought he had discovered a comet, but further observations confirmed it as a new planet. Number 2. Unique tilt and rotation. Uranus is distinct among the planets in our solar system due to its extreme axial tilt. While most planets rotate on an axis that is roughly perpendicular to their orbital plane, Uranus is tilted at an angle of about 98 degrees. This means that the planet essentially rolls on its side as it orbits the Sun. This extreme tilt is believed to have resulted from a massive collision with a protoplanet early in its formation. Number 3. Mysterious interior composition. The composition of Uranus's interior is not well understood, but it is thought to consist of a small rocky core surrounded by a thick layer of icy and rocky materials and topped with an atmosphere primarily composed of hydrogen and helium. Unlike Jupiter and Saturn, Uranus does not exhibit a significant internal heat source, and the exact nature of its internal structure remains a subject of scientific investigation. Number 4. Extreme seasons. Due to its extreme axial tilt, Uranus experiences very unusual and prolonged seasons. Each pole is in darkness for about 42 Earth years, followed by a period of continuous sunlight lasting another 42 years. During the equinoxes, when Uranus is side-on to the Sun, the entire planet experiences a day and night cycle similar to Earth's. The last equinox occurred in 2007, and the next one is expected around 2049. Number 5. Ring system and moons. Uranus has a system of rings, although they are much fainter and less prominent than the well-known rings of Saturn. The planet has 13 known rings, and they were first discovered in 1977 by astronomers using data from the Kuiper Airborne Observatory. Uranus is also orbited by 27 known moons. The 5 largest moons are Miranda, Ariel, Umbriel, Titania, and Oberon, each of which has unique geological features, including cliffs, canyons, and icy plains. Neptune, the 8th planet from the Sun, is an ice giant. Known for its powerful winds and the captivating blue atmosphere, Neptune's enigmatic features include the Great Dark Spot and a faint ring system. Buckle up as we discover the blue giant Neptune. Number 1. Distant giant. Neptune is the 8th and farthest known planet from the Sun in our solar system. It is classified as an ice giant, and its average distance from the Sun is about 2.8 billion miles, 4.5 billion kilometers, making it the most distant of the gas giants, Jupiter and Saturn, in our solar system. Number 2. Blue atmosphere. Neptune's atmosphere is composed primarily of hydrogen, helium, and methane. The presence of methane gives Neptune its distinct blue color. The methane in the atmosphere absorbs red light, reflecting blue light back into space. This atmospheric composition sets Neptune apart from its gas giant counterparts, Jupiter and Saturn. Number 3. Powerful winds. Neptune boasts some of the most powerful winds in the solar system. Wind speeds on Neptune can reach up to 1,200 miles per hour, 1,930 kilometers per hour. These high-velocity winds are believed to be driven by the planet's internal heat, as well as its fast rotation, completing a full rotation roughly every 16 hours. Number 4. Great Dark Spot. Similar to Jupiter's Great Red Spot, Neptune has a feature known as the Great Dark Spot. It's a massive storm system that was first observed by the Voyager 2 spacecraft during its flyby in 1989. The storm is an anticyclonic system, meaning it rotates counterclockwise, and it has been compared to Jupiter's Great Red Spot in terms of its size and intensity. Number 5. Ring System. Neptune has a faint ring system, which was discovered in 1984 by the Voyager 2 spacecraft. Unlike Saturn's prominent ring system, Neptune's rings are relatively faint and difficult to observe from Earth. The rings are composed of small, dark particles and are thought to be relatively young compared to the age of the solar system. There are 5 main rings: Gale, Leverrier, Lassell, Arago, and Adams, named after astronomers who made significant contributions to the understanding of Neptune. Thank you for joining us on this space adventure. There's a universe of exploration ahead. Stay tuned and subscribe for new videos featuring Space 5.